In most cases, when you're dealing with deep learning, it's advisable to have some kind of GPU, to have access to some kind of GPU. So we have a lot of that's available. So it's not a must for you to have a PC that has a GPU. You can always use some cloud-based GPU for your work. So we have so many algorithms. We have key algorithms like convolutional neural network, which is called CNN. We have current neural network, which is used, yeah, is one of the popular algorithms out here there. This can be used for text as well. We have transformer, which actually transform AI words recently, um, which is good for generative AI LLMs. Like so. Moving on. So machine learning in everyday life. So, application where we can apply it in our everyday life. So one thing we don't understand is that machine learning has been in existence for a while and has been applied to everyday life. And we might not know, but we'll get to know here. So machine learning in healthcare. So applications include the likes of disease prediction, like diabetes, cancer. So there are so many systems that have been put in place that can actually detect some diseases, predict prediction, based on some medical information that will pass to the system and it's going to tell if the person actually have a particular disease or not. So we have AI assisted surgeries. Yeah, we have that. I've watched some videos on that whereby we have some AI robotics that actually perform surgeries on patients. So, and we have an example, which is IBM Watson analysis medical data for diagnosis. That's for disease prediction and some other ones that are in existence. Also, machine learning in finance, we have application in fraud detection in banking. So you see big companies using this. So companies like finance companies, likes of Nigeria, we have likes of Flutterwave, some other banks that are making use of fraud detection in banking. So we have algorithmic trading predicting stock trends. So we have so many people that are predicting trends that are making stock predictions now that they are automating it with machine learning. So we have bots that makes prediction that predicts stocks that and some other related stuff. So example here, powered risk assessments, improving credit scoring. So also machine learning in retail and marketing applications include personalized recommendation like Amazon, Netflix. So like I mentioned, Amazon and Netflix, they use the recommendation system. You might be wondering when you watch a movie on Netflix and you will see the next thing that is going to suggest for you is related movies. So maybe you will watch an action movie in the 90s now. So the exact probability that it's going to like recommend some action movies in the 90s for you as well. So that's the work of recommendation system. So it has some algorithms that are being used behind the what's it called the system. We have like the content based content filtering and likes. So we have customer sentiment analysis as well, where some kind of sentiment analysis classify. Take for instance, even what's it called comments sentiment analysis are being done the likes of Twitter, script data from Twitter and some other websites whereby based on people's comments on your product, you can actually know if their comments are actually neutral or maybe it's positive or negative. And with that, you get to know how you serving your customers, maybe you're serving them well or you are underserving them, they apply and fix your products. So example, targets predicting shopping behaviors based on past purchases. So that's an example of retail and marketing and machine learning. So we have machine learning in cybersecurity. Application includes AI-powered threat detection. So you see sometimes when you try to load some things on your website or some things, so you just see some things that pop up like maybe like threats detected and all like that. So that's machine learning. That's the work of machine learning. Identifying anomalies in real time. So some things that your machine might actually see that are not some kind of things that have been introduced to the system before. So we might actually raise some kind of alarm and the like. So that's the work of machine learning. So AI detecting phishing attack and fraud in banking. So I think a similar thing was experienced by some companies recently. I think was it not GT or wherever, and they had to like restrict some customers' accounts due to some detection that they found that some people are attacking people's accounts. Yeah, I think I experienced on my account as well. Yeah, so machine learning is in self-driving cars. I think that one is becoming more rampant now due to Tesla. So application, object detection and navigation. So this with some kind of image, object detection, like image classification, whereby it can actually detect, okay, these are human beings, these are trees, these are, and so it would have been trained with the patterns of the road. So when you see a zebra crossing, then you should know that you should wait, and some other things. So many things is a very, very huge algorithm. Like it requires a lot of algorithms behind it, running behind it. So for it to work perfectly. So we have AI decision making in real time. So that's like an example of all this Tesla as well. So example is Tesla and Waymo using deep learning for self-driving capabilities. So challenges. So with all of we've said a lot of interesting things, but without these things can't be without some challenges and ethical considerations. So challenges in machine learning includes the likes of bias in AI models and data privacy concerns. This is one of the very aspects that is being actually talked about in data recently in AI world recently. Data privacy is a very concern. Like if you're working on some data, you have to go through some kind of data privacy policies before you can use. You can't just get the data and just use it anyhow. You have to like study the data privacy policies and see if it's something that you can actually use that you're good to go with. So data privacy concerns and security vulnerabilities. So these are three of the major concerns. There are some other concern challenges in AI, but these are the major ones. So also the future of machine learning. So yeah, so like we know machine learning AI is something that is still evolving. We don't even know where it's going to now because a lot of things have come up that we even never imagined could have been existing right now. So one of the future trends is explainable AI. Yeah, some people are already working on explainable AI, but it's something that needs to be looked into. It's not circulating yet because what explainable AI does is explain to us. Take for instance, if your model is predicting a disease, then if you need to understand what exactly is going on behind your model, explain your model, tell you which features, and features are combined together that are actually contributing the best to your model prediction. And this will explain to you a lot of things that are going on behind your model. So explainable AI is something that is very important that we need to like look into. We have so many examples of it. We have the like of Lam, we have the like Line, we have the like of Sharp. So explainable AI is one of the future trends. Also, AI in smart cities and automation. So I think it's something that is coming up as well, but might take a bit time. So example include AI-powered robotics evolutionizing industries. So that's about machine learning and its algorithms. So in conclusion, a quick recap, ML is transforming industries, opportunities in AI development, and final thoughts should be machine learning isn't just the future, it's actually shaping our present. So it's not just about the future. You can see a lot of things has changed now, right now. A lot of things are changing right now, and there are still more that are going to be changed in the future. Thank you very much. So, any question? Okay, somebody is raising their hand. Victoria. Yeah.
Thank you so much for that wonderful presentation. It was an insightful one and an educative one for everyone of us. I will believe that everyone has taken one or two things from this session. And then we have another speaker to talk to us about machine learning. I don't know, Mr. Afolabi, we would like us to take your questions now, or probably after the next speaker
Yeah,
presentation.
I won't take it now because I need to go. I need to attend to something in less than 10 minutes.
Okay, yeah, so thank you so much, Mr. Falabi. I have
Yeah,
a
you're
question.
welcome.
I think basically he will just answer questions. I have a question when you spoke about challenges. Yes, you said something very profound. That is, AI is not just our future, it's already shaping the present. And so we need to be very concerned about the challenges involved. And one of it you mentioned was data consent. So data privacy and all. My question is, what are the measures you think anyone can take, should take for when it concerns data privacy in
So,
alignment with machine learning?
when it comes to data privacy, and one very important thing is that, especially when you're dealing with data set that maybe medical data, healthcare data, so you need to take the consent of the patient. So, and I believe not hardly will you see a patient that would want you to like expose his or her disease. So one thing that is commonly done is to remove, or let me say drop, some features that might expose the identity of the patient, be it name, address, email, and some other things, IDs. Might drop them just to have a, privacy. And aside that, there are some privacy, there are some policies that you need to like follow that are there that you need to like follow for you to use some data. So we have some data privacy policies available. I can't really say one for now because I can't really remember. So I know that there are some policies because with some data that I've worked with. So just like sign some policies before you can use that data. And you have to like what's it called? Keep some things, keep some identity or whatever, because they can't just release data to you like that. So even some you have to go through some processes, tell them tell them what you want to use the data for. Is it for maybe research purpose and the like? So when you tell them, they might actually drop some data that felt like they might be private and release data. And if they feel like they might not even release data to you. So, and there might even be, there used to be restrictions based on locations as well. Take for instance, they are trying to get the data of US and you're in Africa here, they might actually not want to release the data for you. On and on. And it happens in Nigeria here as well, whereby you go to some hospitals trying to get something now, like, no, no, can't release our patient data. So that's one of the challenges that we have when it comes to data. So, but if you get some data, you have to like keep some things private. So data privacy is very, very important. And I think it has some kind of punishment if it's being gone against. Yeah. So is there another question? On that answer a question, I put that first.
Yes, yeah. I think what I'm taking home is perhaps maybe let's take for instance anybody that has to do something, wants to do anything that has to do with machine learning, to try to make sure that people's data, private data, are not like necessities, right? There should be some form of security measures to it. And then the example you used is
Yeah.
hospitals and the likes. Thank you so much.
Yeah, you're welcome.
Thank you so much.
Everything.
Do you have any other question from anyone? So personally for me, I would like to ask you about, you mentioned about the features and target the other time. I would like to ask about how do we get to know, or probably if you have a very large data set, how do we get to differentiate which of the variables in the data set we will use as an independent variable, which is the feature, and the one we will actually use as the target variable?
Okay, yeah, so if I get a question right, you asking if you have a data set, for you to determine which one is the target and which one is the features, right? So there are two ways to that. So in most cases, if you are working, I don't know, depending on the kind of work, that if you're working for an organization, or maybe you're working for based on something, in most cases the target is to be defined. But in the cases whereby you're supposed to determine the target, so first thing you need to figure out is, are you working with a regression data, or you're working with a what's it called, a classification data? So you need to figure that out first. And what is the problem statement for what you want to work on? You get? So if I'm asked to predict, for example, the price of houses now, I'm asked to predict the price, and I'm not given a target. I wasn't told that this is our target. So basically, in my mind, I know that what I'm predicting should be price, something prices, you know. So and checking my data, I see bedrooms, I see latitude, longitude, size of bedroom, toilets, if it has toilet or not, on and on. And I see something they just wrote price. You get price, not even house price. They just wrote price. So, and I don't see anything like house prices, but I could see price. At that point, I should know that, okay, yeah, I'm asked to predict the prices of the house, then definitely this should be the column for it. You get? So that's basically that about that one. So also, you might have a data like, okay, you might have a data like data that is maybe you're supposed to predict a tabular data of cancer detection, just to detect cancer. If someone has cancer, a particular cancer, maybe breast cancer or cervical cancer, whichever one. So, and you see a column where you have maybe it might not even be tagged, it might not be tagged as target, it might be tagged as okay, yeah, for example, I think I think is breast cancer that uses biopsy. So if you see a column of biopsy and you see yes or no, so that's why there is, before you can't just jump on a data. Let me put it that way. So you don't just jump on data. You have to make your research based on your problem statement. You get? So if given a problem, then you have to do your research first. So there are some instances whereby they might not even use the term that you are aware with. So for instance, you search what biopsy is, so you know that is a type of the cancer. I think it's breast cancer. So then you see a column. Under that column, you see the likes of yes or no. Then you should know that that's your target. So what's left to you, what's left to be done by you is to convert it to your numerical data. So represent no with 0, represent yes with 1, or whichever way you want to represent it. If you have some other values you want to represent it with. So, and you know that that's your target, and the rest of it will be your features. And also, there are some things that you need to drop, just like I mentioned earlier. So, if you have some attributes like features like ID, so ID doesn't have anything to do with your prediction. It doesn't contribute anything to your prediction. So, you can always drop that. You can always drop it. And some other things. that you just have to like do your research. But to get your target, it's either your target is defined or they give you the opportunity to define your target. Maybe they just want to give you as a problem to solve. Yet. So, but in most cases, your targets will be defined if you are working with a supervised data. But if you are working with an unsupervised data doesn't require target at all. It's trying to like derive patterns, just trying to like check patterns. So that one doesn't have what's called target. Do I answer your question?
Yes, yes, yes. Perfectly well. Thank you so much.
Yeah, you're welcome.
No. Um Now for now I would like to read the bio of the second speaker. So the second speaker to speak to us this afternoon is by name Babalola Olaoluwa. Olaoluwa is a data scientist, a software engineer, and AI researcher. He's an individual driven by deep passion for Python rather, not just as a language, but as a tool to unlock data's mysteries and build solutions that matters. His journey in tech started with keen interest in how software can transform life, which led him to dive into the depth of data science and the dynamic world of web development. So beyond coding, Olaoluwa is passionate about music, African literature, and being part of a community that fosters interrelational learning from each other. So permit me to welcome Olaoluwa Babalola.
Thank you. Thank you, Miss Miriam. Please, good afternoon, everyone, actually. Thank you. Let me share, let me first do video. See, I'm working properly. Yes. So, good afternoon, everyone. Please, can I get the nod if everyone can hear me, please?
Yes, I can hear you
Yes.
perfectly well.
I can hear you as well.
I can hear you.
Okay. Thank you very much. Thank you very much for the opportunity given to me today. I happen to be an intern at Bincom Dev Center currently. I'm an intern here of the Python data science team. So yes, once again, I thank you very much for the opportunity, and I appreciate our first speaker in the person of Mr. B for the insights and knowledge that you have passed on to us today. While going through during your presentation, I had more insight into how AI how AI works, how the relationship between AI and all of these different machine learning models that we are trying to explore today. So without wasting much of our time, let me share my screen. I believe Mr. Beep has made a whole lot of reasonable, insightful comments about machine learning models in general. And I believe, well, there is not much I can say towards the theoretical part that Mr. Beep has already explained to us. Well, I believe my thought process towards navigating machine learning models has been much more technical and practical, so to say. Where I believe I'm a type of person. If you're a type of person that likes to ask questions, I believe, like, okay, why this? You would get to realize well, that happened to be my thought process that geared my learning of machine learning models towards how I can predict, how I can make insightful predictions from different data models. Okay, I'm giving a data set that has previous transactions between a shop that I own, and I'm trying to predict whether, should I continue in the business of producing this particular type of commodity for these people. So if I've been given a particular data set that has previous shopping behaviors of people around me, checking on with their demography based on this. So I believe that is the main usage of all of these machine learning models actually, where they can help me to make predictions on this particular they can help me to make predictions on a new data set where I have trained a similar data set with a particular machine learning model. So let me believe I should share my screen. So please, can I get a signal if everyone can see my screen and hear me properly? Because I feel like my connection is unstable.
Yes, I can see your screen.
Hello?
Oh, I can see your screen. Can you hear me?
Oh, okay. Thank you very much. So exploring machine learning algorithms, actually. So well, I would start my presentation by introducing us to machine learning itself. So what are machine learnings majorly? Machine learning model is a program that is used to make predictions for a given data set. A model is usually built by a supervised machine learning algorithm, whereby this particular algorithm takes a known set of input data, and with this known set of input data, known responses to the data output as well. And it goes ahead to train a program, a machine learning model now. We call it a program. It is a program. I defined it as a program that is used to make predictions for a data set. So it trains this particular program to generate reasonable predictions for responses to the new data that we are trying to make predictions on. So this presentation would cover the fundamental types of machine learning, focusing on supervised and unsupervised learning approaches. We will get to explore different types of algorithms that can learn from and make decisions on data. So I would not make a very good explanation if we don't describe it to the major types of machine learning models. So there are three main types of machine learning models actually. We have the supervised learning model, whereby the supervised learning model is a type of learning model that learns from an existing trained labeled data. So in supervised learning, actually, it learns from an existing trained labeled data, involves providing the algorithm with input-output pairs, allowing it to learn by example. And also, uh, supervised learning applications range from predictive analysis to image classifications to data numerical classifications itself. I talked about prices, predicting prices of a commodity based on past shopping behaviors, based on responses to that particular commodity that you have probably gathered over the internet. So to unsupervised learning involves training a model on data without labeled response. Remember, in supervised learning, we have our responses labeled, but with unsupervised learning, there is no labeled responses. The model just tries to identify patterns and structures in the data without predefined labels. Key techniques where include clustering. Those are the type of algorithms that are under unsupervised learning. By the way, we'll get to discuss more about it in the slides. So, and the third type of machine learning model is reinforcement learning models, actually, which is a type of model that learns by cumulative, it learns by cumulative reward, whereby machine learns on its own. There is an agent that you train, you pass responses to it, and this machine gets to learn by its own. So also under reinforcement learning, actually, there's the definition of desired objectives, like what you want this model to achieve. It is passed on before you train the data set, sub goals, penalties. Probably you want a process of reward and loss for your machine learning model based on its goal achievement. So this is the type of learning models that are under reinforcement learnings. And we should all of these models, they are they fall into agents that there is no predefined environment. I'm sorry for my slow speech. There is no predefined environment in them. They can just be in a new environment, and they then train them where an agent just learns to make decisions by its own. It adapts to this environment. So all of these models, where you have to use these models, you have to take into consideration the environment that this model would be in, the type of amount of data set also. So the agent explores the environment and receives feedback in the form of reward or penalties for partial goal achievement. I said it. So, okay. So going by applications of reinforcement learning, where you can apply them is into robotics, game playing, self-driving cars, whereby you all of these agents, like there is a type of learning model that has been embedded into them to make them perform and give suitable responses like that. So without further ado, I would go into the different types of algorithms that we have in all of these different types of machine learning models. And just so for clarification purposes, we can say an algorithm is not a type of machine learning model, but we can describe all of these machine learning algorithms as a method for solving a particular problem. So when they say, "Oh, give me, write me a machine learning algorithm that predicts whether this set of emails is whether this set of email are spam or they are not spam." So there is a set problem that you want to tackle that way. So this helps you to narrow down, oh, which type of machine learning algorithm would I be employing to this particular set problem that would give you better responses, better predictions, since we are mainly focused on our prediction set. So all of these things are very critical things that we take into consideration before choosing whether, oh, this particular machine learning algorithm is suitable for this set problem that I have. So I'll go ahead to describe some algorithms that are found in that we can use for supervised learning models or algorithms. So we know supervised learning can actually be categorized into two main types of algorithms majorly, where we have the classification algorithms and we have regression algorithms also. Okay, where so Under classification algorithms, we are classification algorithms mainly they are the type of algorithms that are used when our output is discrete. When our output is discrete, and what I'm looking for is a response in form of a yes or no, in form of A or B, one or zeros or ones. Majorly, that is why we actually call classification algorithms binary classifications. So my response, I want it to be in just yes or no format. Okay, is this spam? Is this a spam or not? So that my predicted values will then be is spam. It can be zeros or ones. It can be true or false. Okay, so if I have, oh, this particular person, this email would fall into spam. Yes. This particular person's email would fall into spam. No. So those are the type of this type of data sets are what we perform classification, are where we use classification algorithms majorly. And algorithms under this category include logistic regression, key nearest neighbors. We've seen a whole lot of this discussed by Mr. Abib. He has passed on very good presentation at the time. So also we have regression algorithms also where regression yes, where regression algorithm majorly is they predict continuous outcome. Our output, if my output is continuous, majorly used in uh, majorly used in numerical database. If my output is continuous, when I'm estimating the numerical value, like house prices, my shopping prices, all of these things. If it is in numerical format, then these are places I can use a regression model when the predicted is numerical in nature. So and under unsupervised learning algorithms also, this actually involves clustering algorithms majorly. Is also for classification too. Clustering is also a classification type of algorithm where it sorts data into specific categories using a labeled data set. Uh, when the data clustering algorithm is majorly used when the data needs to be organized to find patterns. In the case of a product recommendation, if you are looking for patterns where this product has been is most used in a, let's say you have a demographic map of how, and then you want to recommend this particular product. So based on labeled data sets that you have, you can make recommendations that, oh, this particular product can do well in this particular state, can do well in this particular country. If you understand, yes, what I mean. So we also have dimensionality reduction algorithms, which are the type of algorithms that they reduce the number of variables in a data set while retaining essential information, often used for visualization, noise filtering, or as a pre-processing step for other algorithms, e.g. simplifying data before feeding it into another model. So if we have this, the use of dimensionality reduction algorithms mainly fall into places of large data sets, whereby I can pre-process these particular algorithms. They help you to pre-process your large data set, and then you can pass them into another data set to before feeding into another model, into another learning model to then help you, that would then help you make predictions on the particular data set. So algorithms under this category includes linear regression, ridge regression, lasso regression. Linear regression also falls under regression models too, actually. So, and then we can see it also falls under unsupervised learning algorithms also. So, and for reinforcement learning learning algorithms, we have the positive reinforcement learning, where algorithms are used to train models where I used to train models to learn by receiving rewards for positive actions, aiming to maximize the total reward over time. E.g., an AI game improving its strategy by earning points for good moves, whereby
All right. Hello, please, can anyone hear me?
Yeah, I can hear you.
Okay. Yeah, so I think the network is bad.
The network is really bad, seriously.
Yeah, so Hirat, when are we supposed to end? So
By
I'll
2.
just by 2. All right, thank you. So I'll just wait. Let me see if you're joining and
All right.
this session. But then please, do we have questions? Anybody wants to ask questions? You have contributions. We have just 7 minutes left. Okay, the silence means we don't have questions. We can simply say no questions. All right, so since the second speaker is here to join back. I believe we've learned one or two things about machine learning and algorithm, and we should be able to differentiate machine learning from its algorithm. And we've also learned about its application too, and it's really went forward to explain to us that machine learning is being used in our everyday life. So while we are all aspiring, I don't know, okay, I don't know if it's everybody that is aspiring now, but for as many persons that are aspiring to become machine learning engineers, please try to ensure that data privacy is a core concern for all of your applications. So I'll be saying thank you everybody for joining. Thank you so much, Hirat, for being around. We'll just have to end it here. He's still having network issues and it's left to just 4 minutes. Thank you, Helen. Thank you, Susan. Thank you, Alex. Thank you, everyone. Have a productive day.
Thank
Thank
you.
you, Alex. All right,
Yes, thanks.
you're welcome.